So, not only can you use, not only can you write vectors, show that they're perpendicular, vector equations, show that they're perpendicular. You can also figure out what two vectors intersect. So you have two lines, have these two equations. And we need to show that the lines intersect, and we need to find the coordinates of exactly where they intersect, okay? And so basically what you have here is where two lines intersect is basically, you're looking for that point, okay? Now, if this was just like a regular linear type of equation, two lines, right? How would you figure out their intersection point? What would you do?
So they equal to each other.
And so you do the exact same thing here. You set the two vectors equal to each other. So that means that, and the way they're written, you basically have, like before, remember how we did the three equations where we would have 3 plus S1, okay? Or S times 1, right? This top equation would be equal to the top equation in the second line, okay? So that 3 plus S would equal 6 plus 0 times T.
Zero.
Which is 0. You would also have 0 plus S equals 2 plus a 4T.
That's why they love zeros in each other.
And then the last equation would be what?
1 plus S equals
Negative 1 plus S equals
18.
18. Okay? Now, sometimes this will work out nicely where like one of your variables cancels out and then you can just solve it simply. If it doesn't and you have two variables, you do substitution or
Whatever that was.
what's the other one? Elimination. You basically are solving a system here, okay? And so when we look at this first equation, since our T cancels out, we basically have 3 plus S equals 6. And so S is going to equal what number?
2.
3. 3. Because you subtract the both sides. Okay? All right? Now you also want to find your value of T as well. Okay? Because it's always good in the sense of like checking to make sure that you found the correct number, you set up the equation correctly, okay? So if S equals 3, you can use the second equation and plug in to find T. T equals 1/4. Is everybody okay up to here? All right. So now with that, now that you have your S and you have your T, this is that first part where it says to show that the lines intersect, okay? We did this last time, I think, didn't we?
Yeah.
No, we did something,
Perpendicular.
we showed that a point was actually on the line. Okay. Take that back. Okay? So at this point, let's just double check that last equation. This is the whole showing part. This is the first part of the question. So we found our value for S, we found our value for T. Now we're going to use those two values to make sure this last equation is indeed a true equation. If they equal each other, that means they do indeed intersect each other. Okay? That means that this should equal this. So we plug it in, negative 1 plus 3 equals 8 times 1/4. 2 equals 2. So this does indeed prove that these two lines are going to intersect each other because two equations equal each other. As they should when two lines intersect each other. Now to find the point of intersection, we can either take 3 for S and plug it into that equation, or we can take 1/4, which was T, and plug it into that equation. Either one we choose, we will get the same coordinate. Because since they intersect, they should intersect at the same point. Okay? Which one do you want to use? 3 or 1/4? Want to use 1/4?
No, it's not difficult.
It's
It's 0, 1, and 2.
Literally, you add 3 to each of those.
Okay? So these three equations that we had before, okay? Remember, the way they're lined up in the vector is exactly what they represent. The first line represents your what? They'll be your X, okay? The second equation will represent your, and the third equation will represent your z. So when you go to plug in 1/4, it'll give you your x, your y, and your z. So 6 plus 0 is 6, so x is 6. When we go to plug in 1/4 for t, what's y going to equal?
4.
Try again.
3.
3. And then when you plug in 1/4 for t to find z, z is going to equal 2. So your coordinates of intersection you can write it either way. Either way would be simple. Remember, this is the column format. All right. With this example, you're finding where the lines of the equations intersect each other. So you're finding where the two lines intersect each other. So similar to the last problem, okay? If you need to, maybe rewrite it so there's not the I's and J's that can confuse you, so you can just get what the equation is. This one is two-dimensional because all you have are I's and J's, so this is a two-dimensional one. So you're looking for an X and a Y coordinate.
No, I have zeros and ones and I don't even have that. Mine's
Right here. Would you minus 1 and
negative 2.
If you need to, you can always rewrite it in a different format so you can see it a little bit easier. But I goes with your first component, that X value. J goes with your Y, and if there was a K, it would go with your Z. But this is a two-dimensional one. So you would have these two equations. You would have 1 plus 3t equals negative 1 plus 0 times S. 1 minus t equals 0 plus S. These would have been your two equations that you would have had. Not 3 because it's not a three-dimensional one, just 2. You're trying to figure out where they intersect, so you need to find S or T. In this case, you don't need to find both because you don't have to show that they intersect. You're just trying to figure out where they intersect. So here, my S cancels out, so I can take this first equation. So equals. So then you'll have 3t equals a negative 2. T is a negative 2/3. Okay? You could also find S by plugging in. S would be a positive 5/3. When you go to plug it in, 2 negatives here would make a positive 1 plus 2/3. So then to find the actual coordinate themselves, you go back to your original equation and go plug that number in. So you have 1 plus 3 times a negative 2/3 for your first component. 1 minus a negative 2/3 for your second component. So the first one would be a negative 1. The next one will be a 5/3. So that would be the column format, but because it gave it to us in I's and J's, I strongly encourage you to write your answer in that format. Questions? Here's the next one. All right, so algebraically, to determine the values of A and B, since A is a part of point A, any point that's on a particular vector is going to be equal to the equation for the vector. And so what you end up doing is you end up setting up, again, in this case, 3 equations. 5 equals 6 plus t, 7 equals 9 plus 2t, and then A equals 3 minus 2t. Now, like I said, you guys were able to figure out the relationship between, each component in, like the first component in 5 or the second component in 7, okay? Because it has to be the same parameter that's affecting all three points. So yes, t would equal what value? -1. So t equals -1 by solving either of the first two equations. You're able to plug that in and figure out that a equals 5, like you got. Okay?
I did that.
Now, I'm not saying that, I wasn't saying that you were wrong, but, when using this whole idea and this whole process of setting up an equation can really help you when it comes down to
I
later
did
parts.
that. I did that.
I did
it in my head.
Oh, okay.
That's why I don't know how to, I still don't know me.
Alright, so then we do the same thing to figure out the value of b. That's b 13 and -1. It's not the same parameter in this case because it's a completely different component. A was the z coordinate, b is the x coordinate. So you're going to find a different parameter for this. So you have b equals 6 plus t. You're going to have 13 equals 9 plus 2t. And then you'll have -1 equals 3 minus 2t. In this case, t equals what value?
8. Oh, no, not 2. I mean, not 8, but 2. Yeah.
T equals 2. If you use the second equation, subtract 9, you get 4. Divide by 2, you get 2. So when you go to plug in, b equals 6 plus 2, which is 8, which you guys got. Okay? So a equals 5, b equals 8. So then in the points that were up there, you basically have your 2 points, okay? So A would have been 5, 7, and 5, and then B would have been 8, 13, and -1, right? Now it says point P lies on L such that OP is perpendicular to L, okay? Now the thing is that if AB lie on line L, we need to figure out that, do we know what line L is? What is it?
R equals 6, 9, 3 plus T 1, 2.
Did it say that?
Yeah.
Okay. That still work? Okay.
That would work.
Alright, so it gives you that, but the thing is that is just a general equation that is not particular to if OP is perpendicular to L. We know that to determine if two lines are perpendicular, we need to do the dot product, correct? Okay. Now, we don't know where P is, but we do know that OP, whatever it is, when we do the dot product to L, it should equal what number? 0. It should equal 0, okay? Now, we have two particular points on L. We have this already. That's what we found in part A, okay? Now, it would be better to use the fact that we know these 2 points for L to do the dot product with OP, okay? P is on L, okay? So that equation of
6, 9, 3 plus T 1, 2.
we're going to need to use this to represent P, OP, because P is on L, okay? We're going to need to use this to represent OP, okay? We're going to need to use this to represent L to do our dot product, because if we do the dot product with L twice, we're going to end up, yeah, and that's not going to help us there, especially to find the coordinates of P. So we're going to have 6 plus T, 9 plus 2T, and 3 minus 2T, okay? This is basically OP right here. This is OP. We need to do the dot product with L, and what we're going to use for L is not 1, 2, or -2. We're not going to use any part of L. We're going to use the fact that we have 2 points that are on L. What is this vector? What is this vector right here? How do we figure out what this vector is?
8 minus 5, 3.
8 8 minus 5, 3. 13 minus 7 is 6. No,
No, the next one's -6.
and the next one's -6. This has to equal 0.
Why is that OP?
Why is this OP?
Yeah.
Because since P lies on L, that means that it is some point that is on this equation when T is a particular type of parameter. We don't know what P is, so we're basically going to figure out what this parameter is in order to figure out the coordinates of P. And the only way to figure out what this parameter is to do the dot product, since we know that OP is perpendicular to L.
So why do we use AB for the other vector? Because wouldn't that just be the same line?
That's the thing, it's AB is the same line as L. But using this, we actually have a set series of numbers. If we made 3, 6, and -6 a different vector, say we made it the direction vector that was on L, this would basically end up canceling everything out. Okay? So by performing the dot product here, we're going to multiply 6 plus T by 3, 9 plus 2T by 6, and 3 minus 2T by -6. All of these should equal 0 in order for them to be perpendicular. And what you have here is a linear equation that you can solve. So go ahead and distribute, solve for T.
Sure.
3T plus 12T plus 12T.
That's what happened. I left the 12 off. I left the 1 off. Explains everything. Yeah, 27. Yeah.
And then 18 plus 54 minus 18 is 54.
So T equals 2.
Negative. So that is your parameter that you're going to plug in to figure out the coordinates of P. Into the equation for L, because P lies on L. In order to find the coordinates, we need to figure out the parameter, and that's what -2 was. So by setting up the equation, allowed us to do that. So when we go to plug it back in, that's 6 plus a -2 times 1, which is what? 4. That's 9 plus a -2 times 2, which is 5. And then that's 3 plus a -2 times a -2, which is, and there is T. So we're going to find the exact distance of OP. How do you find distance? The magnitude. And so since we already have the value of P, we're going to take those and plug it in. 90, which simplifies to be what?
3 root 10.
And this is a non-calculator problem, so you would leave it like that. Here's the next problem. All right, so the points A and B have position vectors. We have a 3-dimensional one here, relative to the fixed origin 0 or O. So it is 0, 0, 0. Now I have to determine a vector equation of the line L1 passing through A and B. Okay, so remember, vector equations were in the format of R equals vector A plus a parameter vector B. Okay, where A represents a position vector and B represents the direction. Okay? Now we have 2 points here. How do we figure out the direction vector? That's the one thing we don't know. How do we figure that out?
Subtract B from A.
We gotta subtract B from A. Okay? So B is, I'm gonna write it in columns because that, for me, is more of a visual thing. 2, -1, 2. So when we subtract that, we'll get what?
-1, -1, -3.
It's 3 minus 2.
1.
So it'll be 1. So that right there would be your direction vector. That goes in for the B in the equation. Okay? We did not have the direction, so we had to find it. And then what we're going for A would be either of the 2 position vectors. It could be A or it could be B. It really doesn't matter. Okay? Because it goes through both of those. Everybody understand that? So let's just use A since that's the first one. And because, again, it's given to us as I's and J's, we want our answer to be that way. So it's going to be 2 vector I minus vector J plus 2 vector K.
You have to write it like that.
I would just because it's given to you that way. Plus your parameter times your direction vector, which would be I minus J minus 3K.
So given just direction vector, you can't get magnitude.
Say it one more time.
If you're just given a direction vector, you can't turn magnitude from it. If you're just given just the R equals A plus T.
Oh, well, correct. It would be, well, in those cases, it wouldn't be, there would be no direction. It would be, you know, I've never seen one that hasn't been without a direction.
No. Like, if you get a vector written in that form with the direction, it would look like the form. Just A plus TB. Like, just like that R right there, that's all we have, that's all we're given.
Mhm.
Would we be able to get magnitude from that?
Yes, whatever the direction is.
We don't have it in, like, we don't know how long, we don't have like an magnitude.
True. There'll probably something else that
Yeah.
be given, then you will be asked to find the magnitude of that. Now, it says line L2 has a different equation. It says show that the lines intersect. How do you show that lines intersect? You got to do what? Set them equal to each other and then find what? When you set them equal to each other.
Parameter.
You gotta find the parameter.
Plug it back in.
And then plug it back in to actually find the point of intersection.
Sorry about your hash brown. I don't really know what happened.
So, let's do that. We gotta set the 2 equations equal to each other. So the one that we just created, okay? That's 2 plus T equals 7 plus 2S. Did everybody see what I did there? I took the first component, the I's, in both equations, I set them equal to each other. Okay? Then it's going to be -1 minus T equals 3 plus S. No?
Because there's no J. It's just
Thank you.
That's why that form's bad.
Thank you.
That's why you had to write it in the
And then 2 minus 3T equals 3 plus 2S.
6.
No, it's 2S. I don't know what you're looking at, but there
What
ain't
about the
no 6 on
3K?
the paper.
That's 3 right there. That 3 is that 3. Now, in this case, we don't have one of those nice ones where T goes away for one of the equations, so how are we going to solve this?
It's already set up, so just take the S and plug it into the S. S equals 1 minus negative T, negative 1 minus T, plug it back into the other one.
Yep, you can use substitution. Plug this in into one of the equations and solve. So, it's going to be, I'm going to just use the bottom equation since it's there. Yeah, I'm just using the bottom since I have the space there. And I'm basically going to solve for T. And T equals 1. When I go to plug that in, yes, S equals -2. find the actual point of intersection. You have to plug in either of your parameters into one of your equations. Since I have the space here, I'm going to use 1 for t. So that's going to be, for my x coordinate, that's going to be 2 plus 1, negative 1, minus 1, and 2 minus 3. So my vector is going to be 3, negative 2, not my vector, my intersection point is going to be 3, negative 2, and negative 1. That is my point of intersection. This is C. Questions? Now I have to find the length of AC. I have to find the length of AC. I have C. I have A from the very beginning. So in order to find the length, I actually have to figure out what vector AC is. Is everybody still with me? Look up, instead of me scrolling. What was A?
2, -1, 2.
Okay, so that was A. C, I have it right here. So how do I find vector AC? What do I do?
Subtract C.
I have to subtract C from A. What's 3 minus 2?
1.
What's negative 2 minus negative 1? And what's negative 1 minus 2? There's the vector AC right there. So to find the length, what do?
Magnitude.
Magnitude. So the magnitude is what? Square root of 11. And the last one, it says find to the nearest degree the acute angle between L1 and L2. You have to use the what? You gotta use the formula.
The angle between two vectors.
Okay? So you're going to do the dot product between L1 and L2, and then you're going to do the magnitude.
Does that mean we should plug S and 1 in S and T into them? And you just do the regular.
What do you use between the two lines? What do you use on the lines?
The direction.
The direction vector. So look at L1. Look at L1. I'll scroll back if we need to.
1, -1, -3.
Okay? Determine the equation of line L. Okay, it was this right here. So you're going to use this vector. That's L1. And L2, you're going to use this vector. That's what you use. You use the direction vector when you're trying to figure out the angle. Does everybody have those? Find the dot product between those.
Miss Anderson,
Yes.